Next, we also promised to talk about a system-level framework and design considerations with regards to that. We touched it before, but there's a challenge for designers of automotive systems today. Building a real-time system is not easy. And the systems of today, they require more features, more functions, leads normally to more ECUs, which adds to weight and cost to vehicles. What could be done to help there? Also complex specialist design tools with lack of automation, lots of manual work, and that really impairs your productivity and quality in the end. There's a heavy dependence on physical testing and testing, where defects are found late in the process, giving you a steep cost of changes by fixing problems close to the launch instead of early in the design phase. What do we want to talk about, and how can we help talking about this? A modern engineering process requires a digital thread. Today we see that the tools normally cover only one domain, and it's not connected even there. Normally you can see breaks between, for example, the system architecture and the system integration tests. Traceability between there is missing, and by that you can't really see where things are failing. Instead, for the future, you want to run your requirements connected between the different domains. Teams need collaboration. You want to track requirements, you want to track progress between multiple tools, upstream, downstream, down the left side of the V and the right side of the V. And to help here, we also want to introduce the importance of the EE architecture here. So once you've done your system level requirements, you apply it on your EE architecture. For example, the zonal architecture that Brendan spoke about previously. And then the EE architecture distributes the requirements over your electrical network engineering, your software engineering, and your mechanical engineering. Also, your hardware engineering, designing your PCBs, etc. And of course, we at Siemens want to talk about this and how we can help. So, you need a comprehensive digital twin for your system, for your electrical, and for your software, as well as your hardware. And development needs to happen together. So once you work your system, your EE architecture, you want to connect that to your software. You want to run your requirements connected through a tool or an ALM tool that ensures that your software implementation is correct on the application lifecycle management, as well as your full system connection is managed on the product lifecycle system, or the product lifecycle management part, where you can connect your electronics, your software, and running your overall system simulation. So from the left side here, we input the requirements, the system models, the constraints, pull it through the system model, apply it to the electrical network, apply it to the software, distribute it across the architecture, and run it through verification, manufacturing, and services. All in all, a solid integration in place for you and your fellow engineers to run an efficient EE system development.